Dag iedereen, goedemorgen. I'm Sam Vanhoutte, I'm CTO at Codit. I'm going to present in English because you'll probably understand my English better than you would understand my Flemish because I'm from Belgium, as some of you might know. I'm CTO at the company Codit, so we're based in the Netherlands, in Utrecht, Belgium, France, UK, Switzerland, Portugal, and Malta. And we have 150 persons working for the company. What we do is really all based on integration, so that's connecting systems, Azure solutions, so working with cloud, and then of course a lot of IoT. So that's also why I'll be talking mostly about IoT today, and especially on the IoT service in Azure, which is IoT Hub. Okay, so we've been doing IoT with different customers, and of course IoT has a lot of meanings. We've done a lot of proof of concepts that never made it into production. But happily, we also did, quite some interesting projects that really have a rollout, and that's of course where we do it for. This is a picture that I use in every single one of my IoT presentations, because it really shows, without technology, but the phases that you have in an IoT project. We all know it all starts here, but the customers want to be there. Customers want to do their, nice machine learning. They want to do their predictive things. They want to do nice reporting. They want to do integration with their systems. So that's where the value is. That's where customers want to be. But that is the hard thing. Getting this right, getting data from in the field into the cloud, and knowing that the devices that you have and you deploy them into the field, that you can, safely take care of those devices, and once they leave the plant or wherever you deploy them, that you can still have access to them and maybe do updates and all of that. That is a very hard point to solve. And that's something that IoT Hub at least provides a lot of added value features. So on the right side of things, of course, we all know that is where the reference cases are about. That's the nice business value that gets created. So everything starts with connectivity. Connectivity, we typically see three different ways. The direct connectivity is the one that you would find in all your home gadgets, where you have your smart toaster all the way to the smart hair comb, whatever you have. And these things have typically a direct connectivity. Also your smart thermostats, your locks, they typically have a connectivity using sometimes your Wi-Fi, sometimes something built in. So that is something that the device then takes care of everything from cloud connectivity and also the local things. We also see cloud gateways. I don't know if people are familiar with things like LoRa, narrowband IoT, Sigfox. Those things have like built-in connectivity to their own cloud backend. So Sigfox has a chip that does some radio frequency things, and they have their own backend. So if you want to start doing Azure solutions with devices like that, then you don't typically care too much about local devices. You can start on the cloud side of those different backends of your LoRa provider and so on. And typically they have integration points there to the different platforms, including Microsoft Azure. And then one that we see quite often is the field gateway or edge devices. I have a talk this afternoon as well on Azure IoT Edge. So the field gateways is something that we see in things like manufacturing, smart industry, where you have existing devices. A lot of times these devices don't have internet connectivity built in. They can be old, they can be OPC devices that we have for 20 years in the industry. A field gateway would typically take the role of connecting to those devices using the existing protocols and then send everything back into the in the backend, for example in Microsoft Azure IoT. Okay. So quickly, what I said, we have done a lot of proof of concepts. Proof of concepts are typically focusing on the outcomes. You want to do some nice presentations, some business rules, you do simulation of devices, or you have like a very small device and you don't care about connectivity laws and all these things. A lot of times even security is not that important. So you really want to focus on that. Of course, you have to have a business story behind it as well, but that's outside of this talk because it's tech days, it's not business days. But if you then want to take that proof of concept and you want to bring it to production and you want to focus on the other things, then you see that you have to think about, what about reliability? What about my internet connection that breaks? What about if you have a device that suddenly gets hacked or that is using an algorithm that might be outdated in a few years because of whatever happens on security? you want to be able to update that device in a lot of cases. And that's hard. Making sure that your device can be updated over the air is something that you really have to test and harden before you can really safely say, okay, this is ready for production. Because once your devices leave your production floor, you no longer have physical contact in a lot of cases. If you're the device maker, you don't know where the device that you make today will end up, in which house, in which building, in which truck, whatever you are building. So that is definitely something that is important there. And that's why we see that the time that we spend in proof of concept and the time that we spend in prototype in real production scenarios is really different, because you have to spend much more time on connectivity, on reliability, and then you do the rest later on, because software is easy to change. Your cloud thing, we see all these technologies here with CI/CD where you can easily add new features and so on. That's fine, but before you have your first release, you have to spend all your time on the connection and the ingestion side. Okay. So that's about setting the landscape. Of course, we're here to talk about Azure, and Azure is built, of course, as you know, on a lot of services specific to IoT. Microsoft has, and I'm going from the top all the way down to the bottom. So I start with the SaaS offerings they are working on. So you have Microsoft IoT Central. So IoT Central is something that they announced half a year ago, I think, on Hannover Messe. And they claim to have the Office 365 for your device management. So you would be able to have your devices set up. You can define the device model. If you're a builder, for example, you can build your device model. You can build a nice dashboard for your devices, and you can give that to the operators. And the operators can have a nice dashboard and see that device has this parameters, it has some real-time graphs. And you can do some commands, like you can say restart or increase the value of this parameter and so on. So that's something they're working on. It's in private preview. And one of the things that I believe, and based on what I've seen already, is that it's really limited in functionality and especially in extensibility. So this is something that will quickly get you up and running, but it does not have all the extensibility options as you definitely have in the lower stacks. So it's like Office 365. You cannot build every single website in it, but you can quickly start with things. And then you have another one that I'm not too familiar with, but it's linked with the Dynamics platform, the connected field services. That's also something that has a link with the business side for field service things. And then we have IoT Suite. I don't know who has been trying IoT Suite so far already. Not too much people, but it's very easy to do. AzureIoTSuite.com. You log in with your credentials and you just deploy a solution, and it's there after 10 minutes. Problem is that I've seen Microsoft salespeople going to a customer and doing that demo, like next finish, look, and my IoT solution is ready. Then we have to say, customer, it will take you probably this amount of days before your solution is there, because that is really not an end-to-end solution. You should look at it more from an architectural guidance, and they are planning to have probably next week or something, in the coming weeks at least, a new pre-configured solution for remote monitoring. So the ones that was most popular was that remote monitoring, but it was really not extensible. I've seen some things with what is coming, and that looks much more better. And it's also based on a microservices approach, where you will be able to customize and inject your own microservices in that platform. So that looks interesting to start proof of concepts and maybe even to start solutions, because customization is much better. But all of these things, the higher level, so all the way from SaaS to PaaS, are built on the bottom services. So these are the core services, and as I said, IoT Hub is the key. That's where the link is made between the field and the backend of the cloud. So IoT Hub and device provisioning, that will be in my talk today. But then on the left side, we have, of course, the connectivity from your devices. So you have a lot of SDKs from C all the way to embedded software, and of course, Java, Node.js, and C#. And of course, you have the Windows 10 IoT Core and things like that. And then on the cloud side, you have all the data services. I won't talk about that today, but I'm sure there's talks on Stream Analytics. You can do all the open source things like Hadoop, Spark, and all of that. So you have a lot of things there that you can use to build your backend. A lot of times we have used Service Fabric, for example, to have flexible microservices. And of course, on the right side, you have the integration with the rest of your landscape, because of course an IoT solution is most of the times integrated with other things. So think about logic apps, think about notification hubs for mobile, think about, of course, a website and Power BI for visualization. And then the one that will be in my talk, I think at 1:30 in the same room here, is IoT Edge. So that's one that is also in private preview at this point. And that really helps in executing some things on the edge, so close to your devices, in your own factory or in your own truck or wherever the device is. And it executes some logic that you can configure from the cloud. So I'll talk about that this afternoon. So the rest of the talk is really on the IoT hub and the device provisioning for today. Okay? One marketing slide on IoT hub. It scales to millions of devices, and it is true. Of course, you still have throttling limits and things like that. One of the patterns that I really recommend you to read is the service-assisted communication. I think it got first mentioned by Clemens Vasters, who is like the program manager or senior program manager of IoT Hub, at least in the beginning. And the core thing is that the device, you should not treat it as a server. You should not expect your device to have a public IP address that you can call. Because if you have a small device and you have an open IP address, that device has to have a lot of power if it's suddenly a public internet-facing address, because it can easily get hacked. So what we typically see with the service-assisted communication is that your device takes the initiative to open a connection, so outbound only, to a service, and that service is, for example, IoT Hub, and the service takes care of all the denial of service handling, of all the security throttling and all these things. So you have to talk to the service if you want to talk to the device. So you have to talk to IoT Hub on one side, and if you get, let's say, validated and authorized there, then IoT Hub has that trusted channel to your device. And that's much more better than the things that we have seen sometimes. So it scales, of course, it has cloud-facing feedback, and very important, it's based on open standards, protocol-wise. That's something that Microsoft really understands. If you look at the Azure platform, it's not just Microsoft only, it's really open. And we see the same things with these protocols. So AMQP was the initial protocol. HTTP is the protocol that you fall back on if there's no other option. And you have MQTT. So AMQP, MQTT are the ones that have better performance because you open like a channel. It's much more fast than HTTP that has to poll and so on. As I said, you have a lot of SDKs for all of that. Now everything starts with security. We all know that. If you hear a story about IoT, it's either a success story or it's horror because of security. So it's of course based on security from the ground up, and you have different access policies on IoT Hub. So on an IoT Hub, I can create credentials, and I can say, okay, this credential or this shared access signature has these policies. So you have Service Connect. That is, if you want to read from your cloud side, so if you have backend services that want to read on telemetry messages and so on, then you have to have that policy in your thing. Device Connect speaks for itself. You have a device that connects to the cloud. And you can also send on behalf. So that's also something that you sometimes can do. For example, in an administration portal where you still want to send something on behalf of a device. And the thing is that every single device has its own identity, of course. And then you have the registry things. The registry is really to either read, like what is the status, is this device still connected? Or to read and write, to create new devices, to disable a device, to delete a device, and so on. So the registry is like the registry of all the devices that are in the IoT Hub. Authentication, so far are two methods. So the one that is mostly used because you don't have all the certificate hassle with doing these things is device ID and a device key. So it is a device ID. Of course, you don't send the device key over the wire. It's using hashing to do the validations. But it depends on the protocol that you use. So you have HTTP, MQTT, and AMQP, as I mentioned. One of the common practices, but also a lot of companies don't do that, is to actually re-enroll your keys of your devices. So to make them expire, that the device has to refresh the token, because if you have your device keys written on your device itself and that device gets accessed, the storage for example, yet that device, with that device key and that device ID, I can just use the SDK and I can send data. So I could say that this patient heart rate monitor is going crazy, for example, and be inventive. You can do a lot of things with that. So it's always good to have re-enrolling of things. One of the other ones, especially in enterprises, is X509 certificates, where you can have either just your existing certificate registered in the cloud. You can do self-signing as well. And one of the things that is added is the CA. So you can say, okay, this CA from my plant, I trust. And I think that's what was announced, I think only this week. So I can say if I have a factory and they are making devices there and I want to use certificates as security mechanism, I can say that that factory has their own CA, so certificate something authority, exactly. So they have their own certificate authority. I can use their certificate and register that in my IoT hub. And then, as from then, I say, okay, I trust that factory with their CA. So every device that they will provision and create that has a certificate from their CA will be trusted on my cloud site. And it can be combined with this service, which is the device provisioning service. I think this is still in public preview. It got announced also earlier this year. And it helps especially in large rollouts. So we have customers now that are looking, so they have devices they make and they will be deployed worldwide. It's not because your backend is in, for example, Western Europe, that all your devices should be sending to the IoT hub in Western Europe. What makes perfect sense is to have IoT hubs maybe in at least 3 locations, like one in the Americas, one in Europe, and one in the Asias, to have your devices connect. And device provisioning service can help you with that. So a device just has to be able to connect to the device provisioning service, and then you can specify different rules to say, okay, this device will be created on this specific IoT hub in America, things like that. So the concept is really that you link your one or more IoT hubs with a device provisioning service, and then they can be cross-region and even cross-subscription. So the 3 principles you can apply is just evenly distributed. It's like a round robin, so that if you have thousands of devices, around 333 will be in each of the 3 IoT hubs. But you can also do it based on latency, and I think that's the one that is most commonly used, where you know that, okay, my device connects and it will be registered in the IoT hub closest to its location. And you can also statically do these things. One thing that I want to add, this is not easy to use and set up. So they really shrinked a lot of things down. There's, for example, at this point, no C# SDK support yet. I think and I hope that will come. So it's either HTTP, so the REST, or it's the C library. And the thing is that you have to have an HSM, so a hardware security module, like TPM and so on. That has to be in your device. So it's pretty specific, a lot of details. I didn't try it myself, but it's definitely not something that you set up like in a half a day. Okay? Now, one of the things that everything is based on is communication to and from IoT hub. And of course, for that, we have the endpoints and we have routes. This is just an MSDN picture with all the endpoints that an IoT hub has. And I'll talk now about the most common ones. So the thing that everything starts with and that most people use is telemetry stream. So where your device is just sending data into the cloud. This is my temperature, this is the vibration, and you do that every 5 seconds, every minute. It all depends. So that's your telemetry stream. One of the things you can also do is operations monitoring. So if you enable operations monitoring on your IoT hub, you can get some events that you can listen on, because you can listen on the right side of this with your cloud solutions. So you know that if a device gets provisioned, if a device is not successfully connecting, and so on. So you can set some levels on different events like verbose from to error and things like that. And then these events get published. So all these events are documented on MSDN as well. So they have a fixed contract. So you know that if it's a connection event, these are the types of information I have. And you can do whatever the hell you want with things like that. File upload, I'll come back on that one. But you can upload files into IoT Hub. And also command feedback. So if you send a command to a device, you want to know if that command got processed or not. So the ACK is also one of those events that you can listen on. What you also can do is have certain artifacts registered or at least linked with your IoT Hub. So here I'm showing storage account with a blob container, an event hub. So event hub is like IoT Hub, but just with ingestion and not with a device identity. And service bus. So service bus is to do publish subscribe routing. So you can have topics and queues registered. So you can have custom endpoints registered there. And then you can define routing rules. So you can say, okay, on the messages that I will get in, for example, the device messages, the telemetry stream, I will set up some rules. And I will say, okay, if this is a temperature event, I will send it to that blob container. If it's a vibration event of a motor, I will send it to another container. And then, of course, the routing will happen automatically by IoT Hub. So this way, you can already say, okay, without writing any code, just people sending their data into IoT Hub, you can route the data to a storage account based on different parameters in the message. And that already archives a lot of things there, for example. You also have twin change events. I'll talk about that later in this talk. And device lifecycle events. So like if this device gets disabled and so on, these are types of events you can listen on. One of the things that I want to add, I don't know if people have seen Event Grid, at least the announcement or something. So Event Grid is a very promising service that is still in very early preview. It allows you to publish events and to subscribe on events. So you can say, okay, if this event happens, then you should call this webhook, for example. Or you should call a message and set it to my queue. So Microsoft is now talking with all the different internal services teams, like storage is already supported. So you can say in storage, if a blob gets created in this storage account, call this, that's an event, and call this endpoint. And you then have a lightweight microservice. It could be a function, whatever you want to do, that gets that blob event and it does something. So that's again let's say the serverless way. Instead of doing polling, because polling can be expensive, you have to have compute running. You now can just have something that is called on demand by the Event Grid service. So just these types of routing rules are very similar to what Event Grid will do. So they might switch this to Event Grid over time. At least that's what I feel. So before I switch to the device twins, I'll just quickly show you how things work in the portal. So I hope you can see this good enough. So this is my IoT Hub. It's just, file new IoT Hub. You set an S1, S2, S3, or a 3. So you can specify it, the size of your IoT Hub and, of course, the costs. But the most important one is, of course, that I want to show here is these endpoints. So on the top, you can see that I have the file upload notifications, the Cloudtodevice feedback, and the events. So the events, messages.events is the one that you typically use for your telemetry. But as you can see, I can also add custom endpoints. In this case, I have only one endpoint I can add because this is a free event hub. In production, I think you can go up to 100 custom endpoints. And then you can see here, I can say, okay, this is a new event. This is a documentation. I cannot add it here. You can see that I can specify some things. So in this case, I'm sending to a service bus topic. So events that get arrived can be sent to this topic. And how do I specify which event gets routed where? That's what I do in the routes. So again, and I hope you can see this, but I have a route defined that says if 1 equals 1, and that never fails, then you can send the message to this endpoint. So in this case, it's an endpoint, the event, the standard endpoint. But I also have one that says if is defined activity. That means if the message that gets sent into my IoT hub, if that has a property, and a property is something you can set, it's like a name value pair on the context of a message. If it has a property with the name activity, then you should send it to, in this case, the activity topic. So that is my my service bus topic. Okay. And this way I'm setting up routing. So I could say, okay, if it has a message type equals temperature, send it to my temperature storage container. If it's vibrations, send it to the other one. So that's the whole routing I can specify there. So what I will do now is I'll just start the first one of my quick demos. And I have this written in a very interesting tool, WPF. I'm not a front-end guy, as you can see. But what I have here on the left side, that could be my device that is sending a message, and you can see the message payload. It's just a JSON structure that says message, test message. But on the top, that's where I set my context. So it's just name value pair. So it will now create a property on the message, and it will say the activity equals SMS. So I can use that to trigger some things. So if I go back to the portal here, remember that I have is defined activity. So if a message is sent, and that's what I will do, that has a property activity, then that message will be sent to my topic that was there. So my topic, I don't know if you're familiar with Service Bus, but on a topic you can have subscriptions. So here I have a topic that just says IoT actions, and then I have subscriptions. For example, I have an SMS subscription that has a rule: if the activity property equals to SMS, like a text message, then the message will end up in this subscription. And I have another one for email. As you can see, activity equals email. So using this, I'm putting the routing on Service Bus. Where do we use that? That's in, and it's a hyped term, but it's in the microservices approach. So what we often do, we have this type of routing. We have Service Bus getting all these messages. We do filtering on a topic so that the messages get routed, and we actually make sure that a message of that type of event, that should be picked up by our email microservice. And that microservice just listens on its own subscription and processes it. And it doesn't have to care about anything else about IoT Hub, about maybe this is a message for someone else. No, it knows that if the message arrives for me, that's what I will do. I will just, the intent of this message is to send an email, and that's what my responsibility is as a microservice. So that's something that where we often use it. So if I now just send, you can see by the way that the numbers are 0. Zooming in again, so you have 0, 0 messages on that subscription. So I'll be sending now, and zooming in again, an activity one that says text message to be sent. I'm transmitting this one. So it now sends from using the device client from my client all the way into IoT Hub. And I'll do the same with an email and saying this is an email to be sent. If I now do a refresh here, you can see that they have a 0, a 1, so they each got one message. And if I do a read the messages from the email, for example, receive messages. That's strange, but you just have to believe me then. Let's try it one more time. There we go. So it will read all the messages from that specific subscription, and in this case, of course, it's just one, and it has that text that I just sent email to them. So just know that by doing this, you have automatic routing, and you can set up your own, you can decouple your ingestion from your business logic, and that's really something that we consider as a best practices in a lot of cases. Okay? So that was the whole concept of routing. Now, another thing that got added a little bit more than a year ago is the device twins. So on the right side, I have the cloud backend where you will be doing your logic, and on the left side, I have my devices. So every physical device that you register in IoT Hub can get a digital twin. So it's like a virtual representation with some properties that you can specify for yourself in the cloud. And Amazon has that as well, by the way. On a twin, you can set tags. Tags is just a free thing for you to choose. It's like metadata. And it's free for you. It's like a name value pair in a JSON structure, and I think you can go maximum to 9 levels deep. And you can only write and read metadata, so the tags from the cloud side. The device in the field does not have access to the tags. Then you have two types of properties. You have the desired properties and you have the reported properties. Desired properties speaks for itself. I want the device that is here. I want to have the device having a desired property of, for example, you should have 25 Celsius degrees in your room. That's the desired property. So I'm setting that from the cloud side, and the device gets that as an event if he wants. So he can use that and say, oh, I should increase or decrease my heating. At the same point, it can report back on the actual property. I'm not saying that temperature is the best way to do for reporting, because typically you want to see a curve, a history. So I would send that with the telemetry stream. For example, one of the things that I will show is firmware. If my device has an existing firmware version of 1.1 and I set the desired firmware is now 1.2, that device can see, oh, there is a new desired property change. I have 1.1, but I need to have 1.2, so I will take action, for example, to download the 1.2. Things like that can happen. You can also use this for the interval. If you want to change the interval that your device is sending its messages into the cloud, just set the desired property to 30 seconds, and your device can change that. That's one of the things that we often see with these properties. And then the telemetry is what I talked about. The other one is the methods. I'll come back on that one, but that's also a way to send from the cloud to a device a command. So you have a lot of things here, and it's not always easy to know which pattern fits the best to my needs. So I talked about the tags, I talked about the desired properties, and so on. So I'll come back on that in a demo later. Then of course the whole thing with how do you send from your cloud, from your device into your cloud in the backend of IoT Hub. The most common one that is also 100% compatible almost with event hubs is this one, device to cloud messaging. So you can use the 3 protocols there, AMQP, MQTT, and HTTP. And you can send your events as messages to that endpoint. The thing is that on the IoT Hub side, every device has its own queue, and that's the endpoint that you can see there. You have 256 kilobytes of data. That's quite a lot. In most of IoT scenarios, that's more than enough. And of course, the body can be whatever you want. You see that JSON is used especially in proof of concepts, but in reality you sometimes see other things as well. You sometimes see that you have to Avro encode, or people just send byte arrays. So you can send whatever you want, and it has properties, and these properties can be the metadata. It's like the body is in the envelope, but on the envelope you write some metadata that would be in your properties. On the cloud side, if you want to read on this stream, you just use the Event Hub endpoint. So this has an Event Hub compatible endpoint, and that's what you use to process those messages, just like you would read an Event Hub. And it partitions, so you know that if you read on a partition of that IoT Hub or that Event Hub, that all the messages from one device will be all going to the same partition. But of course, in one partition, you will get more, multiple devices sent. Okay? So that's the most standard one that we typically see for telemetry streams. Every 5 seconds, every minute, we send the current status. You have all these events persisted, and then you have the services in the cloud, like time series insights and so on. That's all quite common. Then this is the one that I talked about already, the reported properties, like my current temperature is this. I'm currently connected on Wi-Fi, or I'm currently running on a 4 gigabyte message device. These things you can set. So it's more state information, or a status, a job status that you can set. It has only 8 kilobytes of size, and it is linked with a JSON structure that you can specify yourself. On your cloud side, you can use the endpoint for twin change events. So you can say if an event changes, or if a twin property changes, I want to get notified. And then you have the other one to do an upload to IoT Hub. So we have, for example, a scenario where we are working with a truck company. And of course, all the command and control is happening using these lightweight lightweight messages. But every now and then, they have on their board computer, like they go to a customer and they need to scan a signed letter. That is much bigger than the 256 kilobytes sometimes. So in that case, we still use IoT Hub, but we use the file upload. So it's just upload to blob. It's all abstracted by the SDK. But behind the scenes, it sends actually a message to IoT Hub, calling an API. It gets back a shared access signature. And with that access signature, it can write straight into a blob that is configured with IoT Hub. And once that succeeds, it sends a message to the endpoint, and that's the one file upload notifications, where I can be listening on. So I listen on that, and actually I just get a link to the blob message there. So the blob message, that's what we call the claim check pattern. That's what happens. So you upload into blob, and then you send a link to the blob message over that. But that's all abstracted in that one line of the SDK. I can quickly show that, but it's not too exciting. So on the right side, this is my cloud side. So hello, I'm a separate thread, and I'm listening on that endpoint of the file notifications. And here I will just do an upload of, let's take 300 and a little bit more. So that's more than the 250K that I have, and I'm uploading a database of Access. Go figure that. So I'm uploading, and on the right side, you should get, after some time, boom, that file got received. And you see that the file is now having a link to the blob storage. So in the cloud, I configured the blob account to my IoT Hub. Okay? So that was getting data from the field into my cloud. The other one is getting commands and messages from the cloud to my devices. So command and control. The one that was also there from the beginning is Cloudtodevice messaging. So again, the concept is that your device does not have to be publicly available. If your device is in a factory and it's behind a firewall, that firewall does not have to have any inbound ports. It's just a device that has to be able to connect outside. It has to connect using one of those ports that is available. The good thing is that in the recent SDK of IoT Hub, you have an automatic fallback. So I can say, okay, please connect over TCP, because that's the most fast way. But if you don't have that port, because it's like 5,700 and something, if that port is not open, you can fall back on AMQP over WebSockets, for example, and then you have the basic HTTP ports. So that's pretty interesting as well. Your command has to be less than the telemetry, so you only have 64 kilobytes. But other than that, it's pretty similar. One thing that you have to remember is that this is asynchronous. So you push a command on that queue, and you don't know if that message will be picked up. You can listen on the acknowledgement, but it can be that I'm sending a message or a command to a device, and maybe it's to my car, and I'm driving in a tunnel, so I don't have connection. And if it's the tunnel between Switzerland and Italy, it can be 17 kilometers. Sometimes you don't want that command to be picked up after some time. Imagine that it's like unlock the car, and the command gets when I'm away from the car, things like that. So that's why you have to set a time to live, and you have to think about the time to live. Like if the command is not being processed in less than 5 seconds, 1 day, discard it, and then it can be dead lettered, then you can do some logic with it. So that's very important as well. Then you have direct methods. Direct methods is different. you can only execute a direct method to a device if that device is live, if it's connected. Otherwise, you get a 404 type of thing. And it's also only on MQTT. So this does not work on AMQP. It's only MQTT enabled, and it has a timeout. Like if the device is not being handled and resulted in 30 seconds, for example, that's what happens. So you can send a payload. You can say, okay, switch off the light or dim the light, and this is the 30%, for example. So that's something you can do, and you can get a response back. So you can get a synchronous response back by that device using this protocol. It has support for jobs, and I'll get back on that one. And then the desired properties, I talked about that. That's more for configuration. Like you should update to firmware 15. This is the temperature, and again, my device can be offline. I can just update the twin in the cloud. When the device gets online again, it will get that change, and it will say, I will have to do this thing. So this is also asynchronous. And to see if the desired property got like set, you can use the reported properties. That's the symmetry you can do. Now, one of the interesting things, and that's actually the last thing I'll be showing, is that device jobs. So again, proof of concepts, getting back there, you have 1, 2, 3 devices. It's easy. You go to one device, you go to the other, and you change things. In reality, if you have customers that have a big rollout, hundreds, thousands, and even more devices, you need some structure, and you have that metadata I talked about. And then you want to do some jobs. For example, at a customer, they don't want to update the firmware of their devices all at the same time. Imagine that something goes wrong. So they also have some kind of rollout, just like Azure does. So they set tags on their devices, and they say, okay, these are the ones that we can do in wave 1, because they know that device is, for example, at one of our test facilities, or that's at an early adopter customer that knows that he is like testing. So based on metadata, you can set jobs. So I can say, okay, I will set all the desired properties firmware version 2 on all the devices that are in wave 1, and that could be thousands of devices. So Azure IoT Hub has the job because it's asynchronous. It will try and update those properties. You can also call those direct methods. So you can say restart all the devices in wave 1, and it will try and do that all for you. And it's up to us to monitor that job. So it's asynchronous, and you will see the job, it's queued, it's running, it's finished. And you get some results back, like these are the devices that completed and so on. So that's really something that you have to implement once you get into production and you realize that, okay, I don't want to do device management one by one, but I want to do it based on a group of messages. So quickly, because we're getting close to the end of this talk, what I have done, I have 5 devices running here, and they are obviously not real devices, but these are 5 devices that I will start, and as you can see, they all have a device ID that is different. So this one is Microsoft 7, so 7 would mean it's the Microsoft building and the floor is 7. I have another one that is Microsoft Building 7 as well. I have one that is Coldit 7, Coldit 3, and Coldit 3. So that's actually I have 5 devices on 3 floors. That is just the metadata. So if I go now to the portal and I go to the Device Explorer, if I click one of those devices, like Coldit 3, you see that in my device twin, this is the structure, I have the metadata that says tags, location, building equals coded, and floor is 3. So that's the thing I can do. Location, building, that's something I invented. It could be whatever you want. This could be wave 1, wave 3, up to you. So that is the device twin. Now, what I will do, you can actually query. So I can say in the Query Explorer, give me all devices where tags.location.building equals Microsoft, and I get back all the devices that have that specific thing, right? So that same query I will now use to schedule a job, and that's the last thing before I finish, because I have 3 seconds left. So this is my device job. I'll zoom in first. So what I will do, this is my query. So I say, I will execute this job tags.location.building on all the devices that have coded as building. What I will do, I will set the firmware version to be 3.5.6, something like that. So once I execute that, IoT Hub will start a job. It will query all my devices that have that matching selection criteria, and it will update the properties there. These devices in the console applications, they are subscribed on event. If something changes, they will see, oh, there's a firmware version changed, and I will apply these things. So you can see Microsoft and Microsoft, the top ones, they should not get the message. The other ones are all coded devices, so you should get the 3 devices here after some time getting an update. So let's do the start. So the status is queued, it's running, and you could see now that the firmware version got updated. So I updated 3 devices at the same time with 1 job. If my device would be offline, that job would still be running. I can bring my device online. No, not with the desired properties, but for example with the direct method and so on. Okay, so that's the concept that really changes from a basic IoT solution. If you start implementing these things, you can take it to a more real production scenario. I won't take too much of your time anymore. I'm still here for questions, and otherwise, thanks for your time, and have a good rest of the conference.